Hello everyone, welcome back to OrganiChemVerse. We are not just here to solve problems, we are here to learn how they actually work. Practice makes perfect, so I have left a question for you at the very end of this video. Give it a shot and let me know your answer in the comments. Ready? Let's dive in. As an organic chemist, how do I solve this question? First, I will study the reaction conditions given here. There is an organic molecule with alcohol as a functional group. It is treated with concentrated H2SO4 followed by KMnO4 in acidic medium. Then I will look at the options given. You can see that there is benzene ring in all the options. That means what? This ring is undergoing aromatization. What is happening to this six-membered ring? It is undergoing oxidation because there is an oxidizing reagent. With this much information, start writing the reactions, the products formed in the given series of reactions. When the given molecule is treated with concentrated H2SO4, the first step is attack of this electrophile on this electron-rich molecule. You can see that there are two double bonds. So the electrophile can either attack the double bond or the lone pair of electrons present on oxygen. Remember, these electrons are more easily available for the proton rather than the pi electrons. Therefore, the OH oxygen will accept the proton and it is going to form a molecule like this. Then what happens? Since oxygen cannot have positive charge, it will undergo dehydration. If you are already familiar with this reaction, you can skip this step and you can directly show that this OH goes with the proton as water and then you can form a carbocation. So what is carbocation? It is a reaction intermediate which is electron deficient and it is having positive charge. This is where we are getting the carbocation. Now what should happen? Because there are two pi bonds, the pi bond will stabilize this carbocation through resonance. So either this pi bond or this pi bond can stabilize the carbocation, but we prefer to stabilize it by this double bond. Why so? Because it is going to form one more stable carbocation. The driving force here, why these pi electrons should move here is because of this carbocation, which in turn will be stabilized by the methyl shift. What is methyl shift? The shift of methyl group from one carbon to the carbocation so that it will form a more stable carbocation. You can see this carbocation formed here is a tertiary carbocation. What about here? Earlier it was a secondary carbocation. We know that a tertiary carbocation is more stable than secondary, and this is the driving force for the methyl shift. Then what happens? You have to form the benzene ring. So based on the product formed here, I'm trying to form a benzene ring here. So you have to remove the catalyst, right? So what happens here? Whatever the proton was used up, it is regenerated here and you are going to get a benzene ring in this molecule like this. You can see we have generated the aromatic molecule here. So finally, what should happen? It is treated with KMnO4 in acidic medium. This is a strong oxidizing agent and it always oxidizes the benzylic carbon. What are the benzylic carbons present here? A carbon attached to benzene ring. So this is a benzylic carbon. What about here? The benzene attached carbon. So here also we have benzylic and here also we have benzylic carbon. So all the benzylic carbons will undergo oxidation. So here complete oxidation happens. Therefore, this ring will get cleaved. It will open up. So it's going to form a carboxylic acid product like this. And how many carboxylic acid groups will be formed? 3 carboxylic acid as there are 3 benzylic carbons. Since the reaction condition is acidic medium, what happens? The two of the carboxylic acid, you can take either here or here, doesn't matter because there is a plane of symmetry in the molecule. Then it will undergo the cyclization to form a anhydride. Remember, when two carboxylic acid groups are reacting in presence of a catalyst like acid, it will undergo dehydration like this, and it's going to form anhydride. Since it is happening within the molecule, we are going to get a cyclic anhydride like this. What about the other carboxylic acid? It will remain as it is. So this will be the final product. So how did I come up with this as a final product? Depending on the options we have here. You see there is a carboxylic acid and then there is an anhydride. Therefore, the right option is option B. This is how you have to predict the mechanism of the reaction, and you don't have to write the detailed mechanism in the exam. You can quickly do the dehydration and then you can do the shift of methyl and the double bonds, and then you will know there are three benzylic carbons, hence you are going to get three carboxylic acid. Because they are adjacent to each other, they are going to form the anhydride, hence the final product is option B. If you still have any doubts with respect to this, comment your doubts in the comment section. I'm going to help you with that. And don't forget to subscribe the channel if you haven't done it yet. Thank you.